Hey you guys, for today I'm going to go over the second half of the unit test review, so let's get started. We left off on number 14. So they give us this and they want us to simplify, and this comes straight off of your formula sheet. This is the formula for the tangent of alpha plus beta, and that's it. So let's move on to the next one. They want us to actually use this formula, so I'm going to use the formula here and fill it out. So this would be equal to the tangent of pi over 4 plus the tangent of pi divided by 1 minus the tangent of pi over 4 times the tangent of pi. And then we're going to fill these values in off the unit circle. So the tangent of pi over 4 would be 1, because that's the square root of 2 over the square root of 2 over 2. Plus the tangent of pi, well, that would be 0 over 1, which would be 0, divided by 1 minus, and you just plug those same numbers in, 1 times 0. Well, 1 plus 0 is 1, and 1 minus 0 is 1, and 1 over 1 is 1. And that's it for number 15. All right, for number 16, they want us to find the sine of 75 degrees. 75 degrees is not on the unit circle, so we're going to use a sum or difference, and we want to think about how we could get 75. So I decided to do the sine of 30 degrees plus 45 degrees. All right, and then using my formula, that would be the sine of 30 degrees, the cosine of 45 degrees, plus the cosine of 30 degrees times the sine of 45 degrees. The sine of 30 degrees is a half. The cosine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2, and the sine of 45 degrees is also the square root of 2 over 2. Then we're going to multiply straight across. 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. The square root of 3 times the square root of 2 is the square root of 6. 2 times 2 is 4. So that'll be the square root of 2 plus the square root of 6 over 4. All right, for number 17, they want you to graph negative 2 plus 3i on the complex plane. Remember, that's just the point, negative 2, 3. So for number 17, I go 2 to the left on the real axis, and then, negative 2, yeah, and then up 3, negative 2 up 3, and boom, I'm done. Easy. All right, for number 18, it wants us to find the midpoint between these two complex numbers, and we just use the midpoint formula. So think of this as negative 6, 2, and this is 2, negative 6. So I'm going to add my x's and my y's and divide by 2. So that'll be negative 6 plus 2 over 2. So my two real parts. And then 2 plus negative 6 divided by 2 in my imaginary part. Negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. 2 plus negative 6 is also negative 4. Negative 4 divided by 2 is negative 2. I'm going to write that back as a complex number, so negative 2 minus 2i. And that's it. All right, for number 19, it wants us to find the modulus, so I'm going to use the formula square root of a squared plus b squared. So in this situation, that would be the square root of 8 squared plus negative 8 squared. So 8 squared is 64, and negative 8 squared is 64. So that's the square root of 128. Now you can simplify this. I can think of that as the square root of 64 times the square root of 2. So that would be 8 times the square root of 2. And that's it. For number 20, they want us to find the distance between these two. To do that, first you subtract and then you find the modulus of the difference. So I'm going to say 3 plus 2i minus 8 minus 9i. I'm going to distribute that negative. So that'll be 3 plus 2i minus 8, and then the minus and the minus will be a plus 9i. 3 minus 8 would be negative 5, and then 2i plus 9i would be 11i. All right, and now I'm going to find the modulus, so I'm going to do the square root of negative 5 squared plus 11 squared. That'll be 25 plus 121, which is 146. They actually asked for a decimal rounded to the hundredths place, so I put that in the calculator, and I get approximately 12.08. And that's all you have to do for that one. For number 21, they want you to graph this. So first I'm going to change the form. So I'm going to write it out the long way. So this would be 6 times the cosine of 5 pi over 3 plus I times the sine of 5 pi over 3. And then we just need these unit circle values. So the cosine of 5 pi over 3 would be a half. And then the sine of 5 pi over 3, that would be negative the square root of 3 over 2. And then I'm going to distribute that 6. All right, a half of 6 is 3. And then when I do 6 times negative 3 over 2, 6 times negative the square root of 3 over 2, 2 will go into 6 3 times. So that's negative 3 square root of 3. So I'm actually going to write that a little bit prettier. So 3 minus 3i square root of 3. Now if I wanted to graph that, 3 square root of 3 is about 5.2. So that's like the point 3 comma negative 5.2-ish. So let me get my graph paper. So this is number 21. So over 3 and then down about 5.2. So about right here. And that'll be it. Okay. Let's look at the next one, number 22. Wants us to change it to complex form. So I'm going to pretty much did what I just did to graph that point. So let's write it out the long way. So 4 times, now the cosine of 7 pi over 4 is the square root of 2 over 2. That's on your unit circle. And then the sine of 7 pi over 4 would be negative the square root of 2 over 2. I'm going to distribute that 4. And the cross reducing like in the last one, 2 will go into 4 2 times. So that would be 2 times the square root of 2. I'm going to go ahead and put minus because we got this negative. Same thing, 2 will go into 4 2 times. So 2i square root of 2. And that's going to be it. All right, for number 23, they want me to plot this point and then change it to polar form. So first, this is the point negative 3 square root of 2 and negative 3 square root of 3. And we just said that's about negative 5.2. And then negative 3 times the square root of 2 is about negative 4.2. So number 23. 4.2, 5.2. All right, so negative 4.2. Oh my goodness, 4.2, 5.2. Old people problems. There we go. I just made my circle big. Looks great, right? All right, and then let's change the form. Whoops. So let's find r. R would be equal to the square root of negative 3 square root of 2 squared plus negative 3 square root of 3 squared. All right, remember, you're going to have to square both parts. So negative 3 squared is 9, and the square root of 2 squared is 2, and 9 times 2 is 18. Same thing over here. Negative 3 squared is 9, square root of 3 squared is 3, and 9 times 3 is 27. So that would be the square root of 45. I can think of that as the square root of 9 times the square root of 5, which would be 3 times the square root of 5 for r. And now I need to find theta. So I'm just going to do a quick sketch. Think about what our graph looked. Well, let me just get our graph here. So if we made this a triangle, now theta is going to be all the way around here. So let's find this little angle. I'm going to call it alpha. We know from here to here is pi. So whatever we get, we're going to have to add pi to it. So we went down 3 square root of 3 and over 3 square root of 2. So we would be doing the tan inverse, or well, first we could say we got to do the tangent of alpha would be equal to opposite over adjacent. So alpha would be the tan inverse of all that loveliness. Now I'm going to go ahead and cancel those 3's out. So the square root of 3 over the square root of 2. Totally going to use the calculator for that. And I get a decimal, it's about 50.8. And since they're doing degrees, pi is 180 degrees. So theta would be 180 plus 50.8, which is 230.8. So when I put all this loveliness together for an answer, we get 3 square root of 5 and then cosine of 230.8 degrees plus I times the sine of 230.8 degrees. Beautiful. All right, 2 more. For number 24, they want us to multiply these two bad mama jammas, so I'm going to do an old school full first. So we've got 3 plus 3i times negative 5 plus 5i. So first would be 3 times negative 5, which is negative 15. Outer would be 5i times 3, which is 15i. Inner would be 3i times negative 5, which would be negative 15i. I like where this is going. 3i times 5i would be 15i squared. Well, these two are going to go whoop, cancel out. We know that I squared is negative 1, so we have negative 15 minus 15, which is negative 30. So that would be like negative 30 plus 0i. All right, so let's go ahead and think about how that would look if we graphed it. Super quick sketch. So we would go over to negative 30 and we would put a point. So theta is going to be pi. Okay? And if they ask for degrees, it would be 180 degrees, but I'm going to go with pi for this. All right, so we got our theta. Now all we need is our r. So to get r, it's going to be awesome too. R will be the square root of negative 30 squared plus 0 squared. Well, that is the square root of 900, which is 30, right? Okay, so now we can put all that together, and the answer will be 30, goes out front, your r goes out front, and then cosine of pi plus I times the sine of pi. And help if I scoot over there. Ta-da! And for the last one, it's a doozy. All right, we got to do 2 plus 2i to the 7th. So remember, they want you to change that to polar form first. So let's get our r. R would be the square root of 2 squared plus 2 squared, which is the square root of 4 plus 4, which is the square root of 8. I can think of that as the square root of 4 times the square root of 2. So R is going to be 2 times the square root of 2. Now this is in quadrant 1, so we can just go ahead and say the tangent of theta will be 2 over 2. We went over 2, up 2, so boom, that's our whole angle. So theta will be the tan inverse of, well, we know 2 divided by 2 is just 1. And we know the tan inverse of 1, it is 45 degrees. Again, just be careful with whether they want degrees or radians and all that good stuff. All right, so that gives us in polar form 2 square root of 2 cis 45 degrees. Now, the whole formula for raising stuff to a power that's in this form is, you know, if you've got r cis of theta, you do r to whatever the power is, cis, the power, times theta. So I'm going to do that over here. N is going to be 7. So we've got 2 times the square root of 2 raised to the 7th, cis 7 times 45 degrees. So 2 to the 7th is 128. And the square root of 2 to the 7th would be 8 square root of 2. So if I put that together, that'll be 1,024 square root of 2, cis. And then 7 times 45 is 315 degrees. Now, if you have to write that out the long way, that would be 1,024 square root of 2 times the cosine of 315 degrees plus I times the sine of 315 degrees. And then if they wanted you to write that as a complex number, I'm going to need more paper. All right, can you see that? Whoa. All right, then you'll fill in these values. So that'll be 1,024 square root of 2. And then the cosine of 315 degrees over in quadrant 4, that would be the square root of 2 over 2 plus I. And then the sine of 315 degrees is actually negative the square root of 2 over 2. Just put little times in there. So when I distribute this, you've got 1,024 square root of 2 times the square root of 2 over 2. I should have went ahead and put a minus. That'll be okay. Plus 1,024 square root of 2 times negative the square root of 2 over 2. I'm going to throw my I over there so we can clean this up a little bit. Well, guess what? The square root of 2 times the square root of 2 is 2. And what's going to happen with those 2's is they're going to cancel. So that's just 1,024. Same thing over here. I'm going to get this negative now, minus. The square root of 2 and the square root of 2 together are going to make a 2. This 2 over 2 will cancel, and that'll be 1,024i. So we have the answer in every possible form that they could ask us for. All right, I hope you guys have a wonderful afternoon. Good luck on the test tomorrow, and I'll talk to you later.